All right, so hey, thanks for joining. Come on in, have a seat. Those, getting set. We're going to talk about high-performing engineering teams and the Holy Grail. I know that on the schedule it actually has a different talk title, so don't worry. It is the same talk, just has been adjusted with some more updated data that I'm going to be talking about. So if you're here looking for the things we've learned during a pandemic talk, it is the same talk, it's just been adjusted for new data. So high-performing engineering teams and the Holy Grail. Let's go ahead and get started. So software delivery has never been more critical to the success of businesses in pretty much every industry. Every company is a tech company now. It's also never been more complex. All the expectations for delivering high quality software experiences have really just kind of skyrocketed with the need to do it fast. So yesterday's things that were really exceptional that really took some time, those experiences now are kind of the expected. It's kind of the rule now, but it also has to be done more beautiful, more intuitive, more powerful, and throw in affordable there as well. But the landscape of all the available tools and services and platforms and architectures and such has never been more complex than it is today, and it's constantly evolving. This probably needs updated because the CNCF just tends to keep adding more and more. So with this rapid pace of change that we see and the challenges of all the different complexities, the question kind of comes up is how can engineering teams not only succeed but beat out the competition? So my name is Jeremy Meiss. I am from CircleCI. I'm a director of developer relations there, and you can follow me on Twitters at I am Jerdog. I apologize in advance, for anything that you might see. It's just me. All right, so back to the tech industry. We've entered into kind of this period of immense change. We have a global economic uncertainties that are out there have presented complexities that are kind of impacting companies all across the spectrum, from the sizes to what type of tools and services that they're building. Amidst all of this environment, the stability, reliability have really become kind of that increasingly important thing to businesses globally. The ability to provide a reliable, stable platform to customers has really become a crucial value metric to engineering teams across all of those spectrums. But it also is continuing to increase the importance of adding that value. So, teams that prioritize robust testing as part of their kind of continuous integration, their CI practices, can save millions of dollars over time. A study done by Forrester a couple years ago talked about that very same thing, and the total economic impact. That should say impact, not impact. It's not some new metric that's out there. But since 2019, us at CircleCI, we've been kind of building and analyzing a lot of the anonymous data that we get from all of the different jobs and workflows that developers run on our platform. And we've identified kind of this set of recommended baseline engineering metrics that are related to CI/CD and have been able to kind of paint a picture of what it means to kind of have a high-performing engineering team and kind of put that into practice. But we don't believe in one-size-fits-all metrics. Every company's different. You are not like the Googles, you're not like the Netflixes, unless you happen to work at one of those companies, then you are, I guess. But that complexity is going to be different for your business. And so, you can't just try and be like those other companies. You have to be like you. And so as we've kind of looked at this data, we've tried to come up with some baseline kind of software delivery metrics and looking at the data points from high-performing top teams in the industry, and then kind of showing some of those key similarities. So we're going to go through a lot of that stuff now. We are not probably going to find that holy hand grenade for your team. You might, and if you do, I'd love to talk to you about that later, really to just shake your hand and give you the high five. But we're going to be looking at some different metrics and the benchmarks that really identify from these three things. Four things, really. The duration, mean time to recovery, success rate, and throughput. All right, so as CI adoption has expanded over the last several years, we've seen teams have had this grow at all costs mentality. But as we've seen really over the last few months, and even the last 6 to 9 months, the complexity of those software systems, while increasing, the cognitive load that developers have to deal with has presented a lot of challenges around maintaining those systems, and has become really overwhelming for a lot of developer teams, and even the operations side. They've created a lot of these situations that we see now where teams are starting to cut corners, and then we start to see systems are going down more, or people are buying companies and laying off the entire staff and then wondering why things don't work. But we're also at this inflection point where stability has really become the main goal. DevOps teams, they kind of have to take away some of that complexity that has started to accumulate and be in a position to help systems recover quickly from those failures. And so a lot of companies have started to kind of institute this kind of a platform team idea that is this, this need for a dedicated team to support that stability, supporting, how the application has become, that complex, and it's become more obvious that they need kind of a dedicated team to kind of wrangle in everything. So you probably have come to this talk kind of with this question of, so how do you achieve elite status through a holistic software developer practice? It could have also been for the Holy Grail if you happened to see my tweet earlier. I promise that while that is a good question, the answer will hopefully not involve any concussions. But I make no promises. So the data, let's start diving into this data. Duration itself, it's the foundation of the velocity the software engineering teams want to achieve. It's measuring that average time in minutes that's required to move a unit of work through your delivery pipelines. It's important in that it's that unit of work does not always mean deploying to production. It could be as simple as running a few unit tests on a development branch, but getting you ready so that you can move things into a production is really that piece. And so duration is kind of that proxy for how efficiently your pipeline is actually working. The core promise of most software delivery practices and paradigms, everything from agile to DevOps, is really that speed and the agility, the importance of taking in that information from your customers, from your stakeholders, and responding quickly and effectively to those signal points. And these rapid feedback and developer delivery cycles don't just benefit an organization or the users. They're also crucial to keeping your developers happy, engaged with what they're doing, and kind of in this uninterrupted state of flow. When you start adding a lot more complexity and things start breaking, developers start it's not as fun. It's not as happy. But we've seen this exclusive focus on speed and how that starts to kind of come, as I mentioned earlier, at the expense of stability. A pipeline starts getting optimized to kind of deliver unverified changes because then that's kind of this highly efficient way, but it's more highly efficient way of shipping bugs to your users, exposing your organization to a lot of risks. And really unnecessary risk, everything from security to just customer satisfaction. So an ideal duration that we've seen kind of from the benchmark and the data is 10 minutes or less. And this kind of comes from it's kind of an accepted benchmark dating back to Paul Duvall's work, very instrumental in kind of this idea around continuous integration that he talked about. And at this range of 10 minutes or less, it is possible to generate enough of the information necessary to feel confident in what you're trying to build. So among the workflows that we've seen across our platform, the data set showed that 50% were completing in less, right around 3.3 minutes, which was our 10-minute. It's far below the kind of that 10-minute benchmark we have. and I'll show some of the comparison data here in a bit, but it is about 30 seconds faster than what it was last year in 2022. So starting to see some interesting changes there. But the fastest, like 25%, was at the, more than, right around like under a minute is how it kind of came in. And then, 75%, that's really kind of getting that 9 minutes time frame. As we start to see the average start to get a little bit higher, that's where we're seeing a lot more of the longer running workflows at the edges that are showing that, doing more testing, doing more, some of those integration tests to make sure that the deployments are better. And so you start, that's where you see the 27 minutes or more in that 95th percentile. Now, many of the teams that we've kind of been able to see continue to kind of bias towards speed rather than, robust testing. And so that number one opportunity that we've identified for software delivery teams to really kind of start to get to that high-performing status is to kind of increase their test suites, their opportunities to have some more robust test coverage. So some of the ways that happens, the larger you have, more insights that get gathered. So adding your integration, unit, UI testing, to across all of your application layers, not just one specific piece. Also incorporating code coverage tools into your pipeline to identify anything where you might have inadequate testing. Also including your static, dynamic security scans, catching the vulnerabilities before so that they're not passed on to your users. And then incorporating your test-driven development practices from the beginning will also help kind of get you to that better test coverage and hopefully get to better duration times. Now, while these changes really may result in longer durations, they are hallmarks of high-performing development teams. When you add more testing in and be able to catch more of those conditions that might affect your users, your duration time might go up, but everything else is going to go down. And so it's allowing you to kind of consistently deliver secure and reliable code. But the next kind of step out of that is to really maximize the efficiency of your pipelines. So that's where you're looking at test splitting, parallelism of your jobs to make sure that you can simplify wherever possible. Also, you're looking at caching your dependencies and other data that probably doesn't change so that you're not constantly rebuilding those things. You set those aside. So like NPM modules, for instance, that probably aren't changing, don't need to change for what you're doing. You don't need to build those every single time. So that's one opportunity around caches. Using images that are kind of custom made for your CI environment is also going to help with your duration times. And then, choosing the right machine size for your needs. You don't need, if you're just building a simple website, you don't need a large, cluster in order to do that. So you can kind of start to maximize some of those opportunities there. So, the path to optimizing the workflow duration is, really kind of combining comprehensive testing practices with kind of this efficient workflow orchestration. Teams that focus solely on speed and not only spend more time kind of rolling back broken updates and fixing all of those failures, but they're also debugging in production and also facing greater risk to their organization's bottom line and reputation and stability. So developers, they're naturally gravitating towards speed, and while platform teams, they get tasked with kind of identifying and eliminating those impediments that keep developers from achieving that velocity, it's not really their only mandate. They also want to set some of those guidelines, those guardrails that kind of enforce quality standards and practices across all of the projects. They're also standardizing your test suites, CI pipelines, making sure the configurations are using like shareable config and some config policies in place that kind of set that that they're delivering better code. Also, it's okay failure, welcoming that there's failed pipelines, especially in your development kind of testing branches. As long as it's a fast failure, is an okay thing. And welcoming that means that your developer is going to be a much better spot to be able to try new things and to look and fix those changes. And then, actively monitor all the different, streams, parallelize all the different pipelines across the organization, but be able to monitor what's happening is going to give you a lot more results. All right, so mean time to recovery. The next kind of piece there, it's definitely indicative of your team's resilience and ability to respond quickly and effectively to any change or any issue that might happen. Feedback from your system or something breaks. In other words, this is really the best indicator of your organization's adoption of DevOps. The maturity of DevOps within your team. But from an end user perspective, for a lot of organizations, nothing's more important than your team's ability to recover from a broken build. Well, customers, they may not notice the steady stream of, granular updates that you're making to the systems. They're definitely going to notice when something breaks. And so you want to minimize that as much as possible. And if something does break, be able to get back to a working build as quickly as possible. But if you've done the work to set up a pipeline that's generating and providing kind of a complete picture of your code health, it's a whole lot easier to get to that. Martin Fowler, in a 2006 blog post on continuous, I think it was on continuous integration, he described kind of that North Star for software teams around mean time to resolve, which was fix broken builds immediately. And that may seem like, duh, but in a lot of organizations, they take a lot longer to get to that fix. Fix the broken build immediately, get back to working. But it's also better to avoid, could it be that it's better to avoid, failures at all costs? No. Broken builds happen. They're going to happen. But with the proper tests in place and the information from, a red build, getting that information as much as possible is going to give those development teams the data they need to get to that passing green build a whole lot better. So that comes back to making sure you have robust testing that's delivering, testing all the aspects and then delivering the signal back to your developers so they can fix things quicker. Okay, so an ideal mean time to resolve, we see through the data and around high-performing teams is that 60 minutes or less on your default branch. So that's your branch that is like your mainline code. Worried more about that and not as much about maybe your development or testing branches, feature branches, because those aren't impacting the customer. You should still monitor those. You should still at least pay attention, and it helps give you a better idea of how your teams are building testing. But in terms of like a benchmark on your development, on your default branches, you want it to be 60 minutes or less. And the ability to do that is very indicative of kind of your team's, ability to kind of avoid some of the worst outcomes. So what we've seen, 50% of workflows recovered in 64 minutes or less. So it's, pretty equal to that benchmark. And it is a significant improvement from, the previous two reports that we've seen over the last couple years, which showed those times of like 73 and 74 minutes. So it's a good, like almost 10-minute difference. The top 25% recovered in 15 minutes or less, which is really good. Top 5 recovered in under 5 minutes, so that can be something as simple as pushing bad code and then realizing, oh, I know what I broke, pushing that again, and getting to that build. So, and that also means your duration times are probably lower. If you can get to a fixed build in 5 minutes or less, that means you probably have a build time duration of 5 minutes, because your mean time to resolve is not going to be any faster than your duration. All right, so driving this marked, change of about 10 minutes, what did we see really change? We've seen a few factors that we kind of feel kind of lead this. One is that, economic pressures that we're seeing now in the macro environment are starting to kind of hit teams in the micro level, and so they're having to prioritize, product stability over, and over kind of growth, so that stability and reliability are more important. And the high performers in the metrics are increasingly relying on platform engineering teams to achieve kind of a steadier and more resilient dev pipelines with built-in recovery mechanisms. So kind of the first step to lowering this is to kind of treat your default branch as the lifeline, the lifeblood of your project, or of organization, your company. Red builds are inevitable, but getting your code back to green should be everyone's top priority. So if something breaks, everybody needs to focus on that. Should not be everybody's like, oh yeah, we're still over here doing this cool feature that probably isn't going to roll out for 6 months. Everybody needs to dive in and help fix. And having that vigilant culture in place, your organization's going to be kind of poised to really leverage the info from your CI pipeline and get those failures fixed as soon as they arise. So one thing to remember, though, is that recovery speed is, like I said earlier, is bound to your pipeline duration. So the shortest possible time to recovery is also going to be the length, like I said. So achieving faster, you've got to optimize your duration, which we discussed earlier, and then you've got to now kind of use some different techniques. One of which is you're setting up instant alerts. Hopefully you all, if you're in engineering teams, you're using tools like Twilio or Slack, PagerDuty, those things that are helping you get that signal quickly and not relying on your users to tell you that things are broken. Your social media manager will be thankful for that. Writing clear and informative error messages also are going to help identify what the issue is, and so that comes back to robust testing. You're also going to want to make sure that you are, having that ability to SSH into a failed build to see what's going on and to be able to work in that and kind of test and maybe even fix the build in that environment to know what you need to fix in the actual build itself is also an important aspect to see what the different resource challenges might be. So platform teams, one of the things that they're able to really kind of do with this mean time to resolve, they can often form that bridge between the organization and the business goals and the actual developer software delivery practices. So emphasizing the value of deploy-ready default branches is an important piece. They're also setting up effective monitoring, alerting systems, tracking that recovery time so that you understand what your baselines are and understand the trends that might be there, both good and bad. And they're also limiting the frequency and severity of those broken builds because they've set up things like access control and config policies that keep set again those guardrails in place. And then they're using things like config and infrastructure as code systems and processes and tools that kind of help build limit that potential for misconfiguration. Automating as much as possible is an important piece with that. And then they're again actively monitoring all of the data that they're seeing to get everything. There's actively monitoring. That's really the key there. All right, so success rate. And this is really kind of another indicator alongside MTTR that kind of shows the stability of your organization, and it kind of helps you with your app development process. But this impact of success rate on both customers and dev teams it's going to vary according to a number of factors that we'll kind of go into. Like, did the failure occur on the default branch, or was it a dev branch? If it's a failure on a dev branch, it shouldn't matter all that much. But if it's on a production default branch, it would definitely matter. Or did the workflow involve a deployment? If the deploy fails, that's more of an issue than if just build getting ready to deploy, because you haven't gotten it out to the users. And then how important is the application, or service that's being tested? So that failed signal that you receive, it's not necessarily an indication that something's really gone wrong or that there's a problem that you've got to address on kind of a larger or deeper level. But it is, the importance here is far more important for your team to understand the ability, or for you to understand your team's ability to adjust and take in that signal and then respond accordingly, which again comes back to the MTTR. There are also many scenarios where a broken build might be tolerated or even welcomed, especially in the development branches. And I try and focus a little, or at least state a few things here, that failure is fine. Any engineering organization that says you should never have a failed build and that you should always have 100% success is a bad organization. And I can't stress that enough. Those types of processes kill innovation within your teams. They don't have the freedom to make a mistake or to try something new because, well, that's gonna dock me. I'm now gonna be at 99.9 instead of 100. And it's this idea that if you stop failure, you're gonna be more successful. And time again, we see that's not the case. So it's important that, that you have organizations that are open to failure, but it's also important that that failure also delivers that fast, valuable signal to your developer team so they know what they need to fix and not just something nebulous. All right, so an ideal success rate that we've seen, 90% or more on the default branches. Kind of talked about that earlier. Failure on your topic branches or feature branches, depending on what your kind of flow is, those are probably less disruptive to your software delivery practice than something on your main line. Pushing something now to production is probably going to be, it's not probably, it's going to be more disruptive to your company, to your users than on a topic branch. So that's why we really kind of emphasize the importance on the default branch, but it's also good to track that on the different branches so that you can see some trends, but don't make those your benchmark. Make those kind of the leading indicators of your team's performance. So the data, what we've seen, success rates on that default branch were 77%, kind of on average, but on the non-default, it was 67%. Those success rates in the default branches, as we've looked, they pretty much held steady over the last, as we've been doing this report. This will be the fourth time we've done the report. While neither number kind of reaches what our benchmark is, the pattern of like the non-default branches having a higher number of failures definitely indicates that companies are seeing more of this, hey, it's okay to be there. So we highly encourage that. Also, when I mentioned that like success rates, we haven't seen them change much over time. We have also seen that the recovery times have fallen sharply, as we talked about, like 10 minutes year over year. So that's another indicator that high-performing teams are starting to show more value around success rates on production over default branches, non-default branches. So the importance of success rate to your team is going to depend largely on how closely your team collaborates. The type of work you're doing in your pipelines, your ability to recover quickly from failures, all those things like prioritizing that resilience is going to help you mitigate the effects of low success rates. It can be tempting as an organization to kind of chase this success rate of 100%. And while it's desirable, like I've said, to kind of have a high rate of success on those default branches, it really means very little if you're not confident in the signal that you're going to receive from your CI system. So, the platform engineers really have kind of a responsibility to look beyond those surface level metrics and uncover kind of the most meaningful data that's there. So they're looking at things like, if there's a low success rate, they're going to look at their MTTR and try and shorten the recovery time. That'll be kind of that leading indicator. They're also looking at understand what the success rate is as a baseline first, and then look for the opportunities for continuously improving the data, looking for maybe flaky tests, those type of things that the gaps in test coverage can be a big indicator. Also, being mindful of the patterns, influences that other factors have. Maybe it's a Friday. If you see the your success rates going down on Fridays, well, that could be an indicator people they're just ready for the weekend. or holidays. We've seen a dramatic decrease in success rate and mean time to resolve over holidays. That's why a lot of companies say, we're not going to do anything over the holidays. So understanding and paying attention to that is going to be important. All right, this last metric is this throughput. And traditionally, this kind of reflects that the number of changes that your developers are committing to in a 24-hour period. And then, looking at different triggers that kind of tend to be unrelated to developer activity, like a change in infrastructure health or new version of some upstream dependency can kind of impact that. And they are starting to emerge more as we've seen kind of CI systems continue to evolve. So, throughput is useful as a measurement that kind of helps you understand kind of the team flow and kind of tracking units of work as they move through your CI system. And when your team is performing at or above these recommended levels, your throughput really starts to put the continuous in continuous delivery. The higher your throughput, the more frequently you're performing work on your application. But also, throughput doesn't really tell you anything about the quality of work that you're performing. So it's important to kind of consider how rich your test data is to help you understand the performance on other metrics like success rate and duration, and how those kind of give you that complete picture. Taking a look at how many builds you're pushing each day, how many deploys, that type of thing, is not really going to tell you how well you're actually performing. Putting it all together will. So having kind of this high throughput score doesn't mean anything if you're if that's your main goal, and then your developers are just, all right, well, I'm just going to push a change here just so I can get that number up. Like that's not good quality code. That's not a right way to do things. So, all right, so of all the metrics, it is really the most subjective to your organization goal. A large cloud-native organization, actively developing like some critical product line, they're probably going to require like far higher levels of throughput versus someone that's starting to just develop a new product or a new feature. Probably are not pushing it as much. They're doing a little bit more of that development. So understanding what your goals are as a company and setting those baselines are important. But it does really depend on what is going to be ideal. There isn't really a universally applicable throughput target because it does have to be set to what your business needs are. So the type of work, the resources you have, what are you able to bring to the project? What do your users want? Like even the expectation of your users is going to play a part into that. So getting all of that, getting the volume of work you're doing, and paying more attention to the quality and impact of that. Now in our data set, as we've looked at it, we have, the median there is about 1.5 times per day that they're deploying, which is a slight increase from that, the 1.43 that we've seen before, and you'll see all these packed in. At the upper end, the top 5% are doing 7 times a day or more, which is pretty much hasn't changed much in that percentile. The average product, though, had 2.9, so really 3 pipeline runs in 2023 compared to 2.8 in last year. So that uptick in productivity is not really it's not really notable, but when taken in combination with the sharp decrease that we've seen in the mean time to resolve, it may reflect that teams are starting to commit to smaller, more frequent changes to limit the impact, especially as we've seen over the last 6-9 months of the changes in the tech industry. And of the 4 metrics that are measured, it is the most dependent on the others. Like you can't push a lot of builds if your build times are your durations are an hour, 2 hours. Or your mean time to resolve if something broken is 3 hours or 90 minutes, whatever that might be. It is the most dependent. So you can't push anything until everything else is in place. So to improve this, it's important to kind of address all the other underlying factors that really impact it. It's also a trailing indicator of the other changes that you have in your process and environment. So rather than set some specific kind of throughput goal. Set a goal that reflects your business need, capturing the baseline, and then monitoring for fluctuations. Platform teams, platform engineering exists primarily to remove those blockers. We talked about that from development teams. And so, providing all the tools and resources necessary to get good throughput and to get all of the productivity out. So it's important that they are mapping the goals of the company to the reality of the internal business situations, customer expectations and such. They're also kind of capturing a baseline, monitoring for those deviations, and then they're alleviating as much developer cognitive load from day-to-day work. Developers, we're people. We make mistakes. And so removing some of that cognitive load, all those manual processes in order to push out a build, removing that and automating as much as possible, that's what machines are really good at. Humans are really bad at repetitive tasks. So automating is going to be a huge part here. So getting some of that cognitive load on the day-to-day work, remove that, would be huge. All right, so when we look at all of these metrics together, over the last, really the last 3 reports, we did in 2019 as well, we can kind of see the change here, where the benchmark is, and kind of see how this all kind of comes together. So measuring, optimizing, all of those things are going to give you a tremendous advantage. Last few things, we still have a minute. The organization's choice in programming language can affect, but it's not as big of a deal. The last thing here we see, the top languages used on the platform that is pretty consistent in the industry. Most of the languages with the fastest workflow duration are scripting configuration, and then you see Python. It's the only language that kind of appears in the top 25 across all these metrics. It has a large, language-specific Docker images that also helps that. Many of the languages that have the fastest recovery times, they have a long history in the dev community, which means you get better support, more, community, new things being added, tools to make that all better. Many of the languages that have the highest success rates are also the ones with the shortest duration. So you see, some config languages there. Perl, Go, Vue offer a lot of package management. And then Hack. It's a PHP superset that's focused on developer speed. So it's going to be able to get more throughput. You're going to see more of that in the systems. So last slide, basically, the last 2 reports are here. The latest report is coming out soon that has all of the background data here and a lot more that I've talked about. Will be rolling out. If you go to this here, you'll be able to get the last 2, kind of see where we're going, and then thank you. If you go to that link there, the circle.ci/Jeremy, fill that out. I will send you a link to the newest report when it comes out. It won't be an automated thing. I will send it to you, so you're not going to get spam. You're not going to get any of that stuff. But definitely, check that out. It's really interesting data there. And find me on any of these places if you have questions. All right, thank you.